All right, so it's recording. Everybody say hi to Grace. Hi, Grace. Hi, Grace. Very good. Oh, that's really cool. Everybody's waving their hands. That's really pretty neat. All right. So let's take a look at the weekly plan and what is happening this week here. So we are topic 18, more inference considerations. I actually think we're gonna wrap this up today. I'm pretty sure we're gonna wrap this up today. And we could have the test on Thursday, or we could have it on Monday. Do we have a preference? Okay, 1 for Thursday, 2 for Monday. I'm seeing ones. That's all I'm seeing is ones. I'm seeing ones. No, I'm still seeing more ones than twos. Okay, test is Thursday. If you have questions, if you want to go over this, like I've done a number of these Zoom sessions, just one-on-one or a couple people. Last night I actually did a little, yesterday I did a little Zoom for a couple of students in online stats. Well, that is a lousy course. I'm just telling you. You don't want to, I'm glad you didn't take that. That's really, they gave them this problem and then didn't even give them the necessary like table to answer the problem. I mean, it was like a quiz. It was like really ridiculous. I was kind of irritated. Okay, and so then we'll have the test on Thursday, and then next week our 2 sessions. We have like 2 regular sessions, and we'll start topic 19. I'm hoping to do like before the end of the year 19, 20, and then 26. That's kind of my objective in my head here. But again, it all kind of depends on how it goes. 19 and 20 are the same thing that we've been doing for 16, 17, and 18, except that they're for quantitative variables instead of categorical variables. So a little bit different, but not a ton different. Not a ton different. And then next week, Thursday, for whatever reason, they decided they wanted to do, all classes are going to meet for 25 minutes. Were you aware of that? No? Well, now you are. All classes are going to meet for 25 minutes. Hang on a second. Am I going to sneeze? No. Okay. So I'm thinking we're going to do an activity. And what we're going to do is I'm going to ask everybody to take a picture of something weird in their house and then send it to me. And then we're going to have a guessing game as to first what the item is, and then who sent it. So my daughter played this game with her coworkers at Uber, and she said it was a lot of fun. So I don't know. 25 minutes. I mean, what are you going to get done in 25 minutes anyway? So we can have some fun with it. Sound all right? So start thinking about like what you want to take a picture of that would be difficult to guess. And yeah, and then we'll figure out who sent it. And so and then there's Easter break, which even though I would have to say it's not going to be a typical Easter break, I would say I am definitely ready for Easter break. I think I'm gonna binge watch Harry Bosch. That's what I think I'm gonna do, is the detective series. I'm gonna binge watch that. I've never seen Game of Thrones. You've seen Game of Thrones? No? I guess that's a little bit, yeah? Ariel seen it? I don't know. People like go nuts over Game of Thrones. I've never seen it, so maybe I'll binge watch that too. I don't know. But by the time I come back after Easter break, I'm gonna be like a TV zombie, I think, So we'll see. So what I'm going to do is I'm going to give you, like 5 or 8 minutes to do some planning. But if you have not completed the survey that I sent out, I would like you to spend the time and just complete that. It won't take very long. Everybody got it, right? Yes? Okay, yeah. So if you haven't completed it, please do so. I do think actually that the stats class has been the best. They've had the highest proportion of completions of all my classes. So, all right, so take about 5 or 8 minutes, and I'm going to turn off my video. My audio will still be on, so if you need something, just call out. Okie dokie. I think we can regather. Good. Okay, let's turn that off. So I do have a prayer for this morning. I forgot first thing, but we'll start with that now. This is a prayer in the time of coronavirus. So even though I'm trying to avoid coronavirus stuff, I kind of thought, well, this would be worthwhile. Dear God, we ask that you be there for us as you were for our ancestors, a pillar in our midst. Help us to turn to you for guidance during these troubled times. Give us strength for the weeks ahead. Help us to reach out in love and compassion to one another, to support those who are ill, unable to leave their homes, or who are struggling financially. Be with our doctors and caregivers, our nurses and scientists, as they are working to develop a cure and care for those who are ill. Be with all who are ill and their families, offering them your compassion and your healing. Be with our leaders, guide them to wise decisions in these troubled days. Be with us, help us to find the inner strength to be patient when our nerves are tested. Be our still waters when we are surrounded by fear and anxiety. Be our rock to whom we can turn and give our worry and fears. Be our shelter, guide our steps, and keep us safe. Help us to feel your presence in these times of change. That's pretty good. I like that. Okay, so let's talk stats. I emailed out a change in the objectives and practice problems because there's certain things that I'm thinking, nah, we don't really need to cover that so well, and other things that would be more interesting to cover as we kind of go forward here. So we've done objective 1 and objective 2, which I would have covered anyways. The significance test, you know, the relationship between significance tests and confidence intervals. And we did objective 2, which was the difference between statistical significance and practical significance, which is really like kind of like use your head. Is it really that important whether it's 0.32 or 0.33? You know, I mean, sometimes it might be, but other times it might not be. And then today we're going to very, very briefly just talk about the limitation of presenting test results based on fixed significance levels rather than p-values. That's going to be very, very brief, just kind of like a concept. We are going to talk about objective 4, which identifies situations in which we should not use statistical inference because the sampling method is biased or because data for the entire population are available. That's an important point. We are cutting out objective 5 and objective 6, which are about, there's like type 1 errors and there are type 2 errors. And, you know, when you get to college stats, you'll probably have to learn that. But, you know, we'll leave that for college stats. It's not like that crucial, and it wouldn't really add that much to our understanding, I don't think. And then we are going to talk about the impact of sample size, significance level, and alternative value on power. So these were the practice problems I had suggested. I crossed off this one 18-20 because it's dealing with types of errors. And then I added a bunch here. I highlighted this one 18 number -26 because I thought it was a particularly good problem, had a lot of meat to it. You know, so those are things that you can do to, you know, well, to practice. Okay. Yes, and I just emailed that out to everybody, so you all have it. Oh, hi, Clara. I want to mark you here. There you are. Grace is still not here. Is Isla here? Did Isla show up? Isla, calling once, twice? No, no Isla. Okay. And Isabella is still not here. Okay. All right, good. All right. So this activity 18-3. The objective is recognize the limitation of presenting test values based on fixed significance levels rather than p-values. So the fixed significance levels, that's when we're talking about, you know, when we say that alpha equals, you know, 0.10 or alpha equals 0.05, you know, where we're giving a very specific number and we're saying if the p-value is less than this, then we reject the null hypothesis. If the p-value is more than this, then we can't reject the null hypothesis. And really deciding what the significance level is in itself a little bit random. I mean, you know, like why the hell does somebody say that it's this and not that? I mean, you know, part of the reason why they might say it's this and not that is if they want their experiment to reject the null hypothesis, maybe they started out with a really low test of significance and they say, oh, well, that's not the result that I want, so I'm going to change my test of significance. You follow what I'm saying here? You know, somebody's trying to basically fudge their results. And that happens, you know. So what this whole exercise is about is it's really take a look at the p-value and then make a decision as to whether or not you think it was significant. Yeah, pay some attention here to the level of significance that the researcher is assigning to the problem, but you know, don't let it necessarily guide your ultimate judgment when you're analyzing the thing. And definitely don't just look at don't accept it if somebody says, well, we reject the null hypothesis without giving you the p-value. You really need to see what the p-value is. So if we have a test of significance of 0.05 and the p-value comes out to be, you know, 0.0499, I mean, I want to know that before I go ahead and say, yeah, I'm going to reject the null hypothesis, because it's really very close. And, you know, if it's really close, then maybe I want to look at it and say, well, I really have a different result here. I don't want to reject the null hypothesis based on that. Make sense? Yes? I'm seeing nods? Okay, good. All right. So that's activity number 3. We're done with that. And let's get over here. Come on. We're not going to do that. I am recording. Okay, so okay, but this one we are going to do. So women senators. So we're going to identify situations in which statistical inference should not be applied because the sampling method is biased or because data for the entire population are available. So an alien lands on Earth, notices that the human species has 2 different sexes. Well, this is, you know, well, two different sexes. Sex is different than gender. I'm like, sex is different than this. And we do have 2 sexes, but we have multiple, a scale of genders. Is that correct? That's it. Okay, good. All right, good. All right, so the alien sets out to estimate the proportion of humans who are female. Fortunately, the alien had a good statistics course on its home planet, so it knows to take a sample of human beings and produce a confidence interval. The alien happens upon the members of the 2011 US Senate as its sample of human beings, so it finds 17 women and 83 men in its sample. Come on now, come on. Where are we at? All right, so I have 17 women and 83 men. Can you form a confidence interval from that? Can you? Yes, you can. Right. Okay, so let's see if you can help me do it. So I'm looking at the magic bowl here.
Mr. Jenkins,
Yes, please.
what number problem is this?
This is, you know what? I'm not sharing the screen with you, am I?
No.
Come on, guys. You gotta get on me here a little bit. Now I gotta share the here. I'm reading everything and I'm thinking, oh, they know exactly what I'm talking about. And we don't. This is 18-4. Now I'm there, aren't I?
Yeah, thank you.
Okay, good. Thanks, Bella. All right. There we go. Okay, that's better. Okay, so I got 17 women, 83 men in the sample. And so I'm going to go 1 to 27. And so I'm going to ask Tati, what is my proportion of women in this sample?
Can you hear me?
I can't hear you.
Okay, all right. 17.
Nope, I want my proportion.
Oh, your proportion?
Yes.
17 over 83. Is it 17 over 83?
Nope,
But that's
but you're getting close. What's my sample size?
one more time.
What's my sample size?
It is it 100?
Indeed it is. Tati, you taking Gov?
Yeah,
How many people in the Senate?
100.
There you go. All right, that's our sample. Right? Come on.
So that's how I memorize it.
All right, so I got 17 over 100. So my proportion is 0.17. Yes? Is everybody okay with that? Okay, that's my and so Tati, what is the symbol that I use for that?
Is it P hat?
If you take away the question mark, then it is P hat.
P hat.
P hat, right? My P hat is 0.17. So I need to find a 95% confidence interval for that. So I'm going to go P hat plus or minus my Z asterisk times my standard error. Do I have enough information to calculate my standard error? I don't? What am I missing?
The standard deviation.
Well, now, so let me think here. I have to think.
Wait, don't you have enough information to find standard error?
I think I do. Tell me, Ariel, how do I find standard error?
You do the square root of p hat, which is 0.17, times 1 minus 0.17 over the number of things, which is 100.
Very good. So this is going to be my standard error. I can find my standard error. Everybody good with that? I'm going to tell you the test is all confidence intervals and p-values. So you really need to know how to do this. So let's call up a calculator here. And you can see the calculator too, right? Yeah, okay, so I got 0.17 times 1 minus 0.17. And then I'm going to divide that by 100. And then I'm going to take the square root. And I find that my standard error is, let's call it 0.0376 equals 0.0376. Does anybody happen to have the chart with the critical values, the Z asterisk?
1.96, if I'm remembering correctly.
1.96?
Yeah, if I'm remembering this correctly.
Okay, so one, I think you're right. 1 point for 95%. Yeah, I think you're right. 1.96 times 0.0376. And then I'm going to take 0.17 plus or minus that. And that's going to give me my confidence interval. So let's do that. I'm going to go 0.17, and I'm going to go plus 1.96 times 0.0376. And 0.17, yep, I got that right. And so I find that my upper end of the confidence interval is 0.24. I got to get my thing to stay on the top there. You always in front. Okay, so 0.2437. And then my lower end of the confidence interval is going to be taking that same thing, but doing it minus and I get 0.0963. So there we have it, right? The proportion of women in the United States is somewhere between 9 and 24%, right? 95%, I'm 95% sure of that.
Well, based off of your sample.
Yeah, I mean, you don't think this is true? That the proportion of women in the United States is between 9% and 24%?
No.
Yeah, we have to take a vote. How many people say that the proportion of women in the United States is between 9 and 24%? I'm not seeing any hands. I mean, clearly the proportion of women in the United States is probably like about half, wouldn't you think? Yes, Allison,
Because it's not representative
louder.
coming from the like from numbers of senators, and that's not like proportional to the population.
Yeah, I would say that our sampling method is extremely biased. I mean, I guess in a way it was random that they decided to pick the U.S. Senate, but nah, I don't think that is a representative of the population. I think we had a biased sample. If we have a biased sample, then all the good math that you do doesn't make any difference because your data is biased. It's like, well, obviously it's kind of silly. Make sense? Right? So really make sure that you're okay, yeah, so make sure that when you take a sample that it is representative of the population. But then let's look at question D. It clearly doesn't make sense to use a confidence interval in part A to estimate the proportion of women on Earth. But, on Earth, in fact, it wasn't even just the United States, on Earth yet, but even still, I think it's about 50-50. It's actually, I think it's like, I think the natural proportion is about 102 women to every 100 men. Were you aware of that? More females are born than males? Yeah, I think it's because women die in childbirth. So they got to have more of them than they do men. But that's my take on it. All right, so it doesn't make sense to use this as estimating the proportion of women on Earth, but does it make sense for estimating the proportion for women in the 2011 US Senate? This is, now read this question carefully, right? Does this make sense? Does finding this confidence interval right here make sense for finding the proportion of women in the US Senate? How many people say yes? Anybody want to say no? Nobody wants to say no. Lily, you want to say no? No, you don't?
Yes.
What?
I'm saying yes.
Yes, okay. Nobody wants to say no. I say no.
Wait, I have a question.
Yes.
This sample population, which year Senate is it from? Is it from like its present day, so 2014?
No.
Or
2011.
okay, so they're both 2011. Okay.
Yes, the data was from 2011 Senate, and yes, the data was from the 2011 Senate, and well, actually, let me take a step back there. I want to double check that. Yeah, 2011 Senate, and the confidence interval represents the 2011 sentence. I say it makes no sense, and I say it makes no sense because I don't. What do I need a confidence interval to do that for? I know that there's 17 women in the Senate out of 100. I know that the proportion is 0.17. What do I even need to do the statistical analysis for? If I can actually measure the entire population, then there's no reason to take a statistic and do inference. I will say that again. If I can actually measure the entire population, then there is no reason to take a statistic and do inference. I just go ahead and measure the population. If I wanted to find out how many girls at NDA are left-handed, I mean, I guess I could take a random sample and make an inference there, but it would probably be just as easy to just put out a survey and ask, you know, out of the 370 students, how many are left-handed, and then I have the proportion. Yes? No? Question? Okay, then let's proceed. Okay. Yeah, so it's just emphasizing here that inference procedures do not compensate for the problems of bias sampling. Bias sampling, the whole thing is ridiculous. Don't even try it. If the data at hand constitute the entire population of interest, then there's no reason to find a confidence interval. I knew that the proportion was 0.17. I don't need to do the confidence interval to find out that it's somewhere around, you know, between this and that, and 0.17 is in the middle. I already know what's in the middle. Okay. We are not doing this one. This is type 1 and type 2 errors. And we're not going to do that. And we're not doing that or that. All right, so this was the okay, so remember we did this the other day, this 18.6, and we went up until, let me see where we went up to. We went up to, yeah, we did up to F to finding the p-value and the intervals, right? Beyond that is talking about type 1 errors and type 2 errors, and like I said, I don't think I want to really deal with that in this class. So really what I thought I would ask you to do is spend the rest of the time working on some of these practice problems, and just kind of, you know, if you want me to set up a breakout group and you want to work in a breakout group, just let me know. Say I want to work with so and so and so and so and so and so. Send me an email or something, or chat, whatever, and I can set up a breakout group, or you can just kind of work on them, and I'm going to be here, and you can ask me questions, and that's what I thought we would do right now. Is that acceptable? Yeah. Okay, great. So again, if you want to be in a breakout room, let me know, and I can set that up. If you'd rather just kind of work on them, you know, on a piece of paper, I'm right here, and I'm not going anywhere. Maybe the cat will come visit, but I doubt it. Okay. Does anybody need the problems? I should ask that, because I don't know, you need, I'm gonna send out the chapter of the book, and then you'll have all the problems there, okay? So I'm gonna do that right now. Actually, let me. Compose P2. Go away. Okay, I just sent out the book for topic 16, 17, and 18. So you should have problems for all of those, which are the chapters on this coming test. All right, so we can stop that share. And okay, so breakout rooms. Sasha, Clara, Natalia. So I got Clara, Natalia, and Sasha. And then I have Bella, Giselle.
Mr. Jenkins,
Yes.
what's the test gonna be like? Like, is it online or?
Yeah, we're just going to do it like we would normally do one in class. I'll like send out a PDF of it to everybody.
Mm-hmm.
And then, you know, you'll sit there and work on it. And if you have questions, I'll like set up a little breakout room so we can kind of go over there and answer questions. And
Okay.
Yeah, yeah, that's kind of how we're gonna work it. Does that sound okay?
Yeah,
Okay,
thank you.
yeah.